Assalamualaikum warahmatullahi wabarakatuh. Welcome back to our online class. Thank you for coming. So today we are going to discuss about mixture of two open compartment system. So the first one is background study. Mathematical modeling is widely used in understanding this concept involving tanks, which is a mixture of two compartment open system. In order to solve this problem, we use Laplace transform. Next is objective of the study. First, it is to learn and have a deep understanding in solving using Laplace transform. Secondly, we want to investigate and apply Laplace transform in the mixture of two open compartment system and certain areas. And the last objective is to solve the systems manually and by using computer algebra system, which is a new thing for us. So the scope of the study is integral transform were extensively used in order to solve the differential equations. It is also used to provide powerful operational methods for solving initial value problems. And now, in this current era, most engineers use Laplace transform in order to solve differential equation with initial or boundary condition. And lastly, it is widely used in compartment model problems such as pharmacokinetics and ecological system.
Okay, then for literature review, compartment system can be involved in one or more variable. It is either arranged in parallel or series. The compartment model can be divided into 4 types, which are mammillary model, catenary model, open model, and closed model. The number of compartment is represented as a box. Meanwhile, a number of arrow is used to show the inflow or outflow of materials from the compartment. So in this project, we focus on 2 interconnected compartment open system, which described as the diagram here. Next, brief explanation of model. So in this project, we use principle of conservation of mass, which stated that time rate of change of the fluid mass inside the tank is equal to the mass of the flow rate enters the tank minus the mass of the flow rate exit the tank. Since our project is involved 2 compartment systems, so there are 2 equations here, where dx dt is the time rate of change of the fluid mass in tank 1. Meanwhile, dy dt is the time rate change of the fluid mass in tank 2. Then Ax and Cy here describe the mass of the flow rate out of tank. Meanwhile, By and Dx here describe the mass of the flow rate inside the tank.
Problem, which is from our textbook, page 577, mentioned that two tanks A and B, each holding 50 liters of liquid, are interconnected by pipes. The liquid flows from tank A into tank B at a rate 4 liters per minute and from B into A at a rate of 1 liter per minute. The liquid inside each tank is kept well stirred. Pure water flows into tank A at a rate of 3 liters per minute and the solution flows out of tank B at 3 liters per minute. If initially tank A contains 2.5 kg of salt and tank B contains no salt, only water, determine the mass of salt in each tank at time t equals to 0 and graph on the same axis the 2 quantities xt and yt, where xt is the mass of salt in tank A and yt is the mass in tank B. So, in order to solve this problem, we need to recognize the equation that need to be solved. So, from this problem, we will get these 2 equations on the right side, and then what we need to do first, we need to perform Laplace transform equation 1, and then we will get ys equals to 50s plus 4xs minus 125. And then we perform Laplace transform for equation 2. And then we substitute ys, which is equation 1, into equation 2. and then we will get XS. And then we will perform inverse Laplace in order to get XT. After that, after we will get XT, and then we substitute back XS, and then we perform inverse Laplace again for YS in order to get YT.
Okay, for computer-aided solution, we use MATLAB in order to get the answer, and after we do the coding, the answer that we get from the manual solution and computer-aided solution are the same. So they prove that the manual solution is the correct answer. Then, in the MATLAB, we get a graph, and from the graph, we can say that the 10A, which is the line blue, with higher concentration than 10B, which is line red. And at one point, the trend will become fixed and uniform as the liquid and salt mix together. The limiting concentration in 10A is 4.1 per 21 kg per liter, and in 10B is 30.7 per 21 kg per liter. We can find the value from the graph. And for the conclusion, after analyzing mathematically, it is confirmed that mass of salt changes over the time, and eventually it will fully mix together with the water, which makes the concentration of the two become uniform. We can see it become uniform from the graph. And the Laplace transform has helped in knowing how to solve the problem. And it gives the answer regarding which tank has higher concentration and how does the concentration change with time. Mathematical modeling for the stimulation of this model helps in formulation a convenient and accessible design, which performs in mixing salt and two interconnected tanks. And for the Islamization, Allah has stated that in the Quran where two seas do not mix with each other, and it is He who has released simultaneously the two seas, one fresh and sweet, and the other one is one salty and bitter. And He placed it between them a barrier and prohibiting partition. This we can find in the 21 verse 53. This applies in this specific problem because it involves the mixture of pure water and salt. Even though in this problem, water and salt did mix ultimately, but because Allah is the most almighty and He knows best. As mentioned in Quran, Surah Al-Alaq, who asked us to read, it shows that Allah asked His servant to reading and to seek knowledge through reading and use it for good purpose. Islam encourages its followers, especially scientists, to do research as Islam and science do not contradict. Thank you. Thank you.